welcome to the chemistry crash course. Today we are going to deal with one more chapter, that is classification of the elements and periodicity in properties. So it is one of the important bit of the basic chemistry topic, that whatever the chemistry which we are know and the elements which are very important, and the elements are the basic things. Okay. So it is very important to know the classification of those elements and how those are arranged in the periodic table. So let us go for the how the elements discovery started. See here, in the beginning of the elements discovery, the scientist Lavoisier, he detected or he discovered 23 elements, and later on the studies goes on increasing, and they have discovered at around 23, after 23, 31 elements, 55 and so on, and nowadays we are getting 118 elements. Previously those are 114 elements, and recently, since from last years, there are 114 elements are again 4 elements are discovered. Okay. And then here let us go for the how the scientist step by step they have discovered regarding the some ideas. Here first Lavoisier invented the 23 elements, and after that there is a one more scientist, Dobreiner, that is Dobreiner law of the trades. See here, it is very important, he called trade. What is the meaning of trade? The meaning of trade is a set of the 3 elements. A set of the 3 elements is nothing but trade. So according to Dobreiner, so according to the Dobreiner law of the trades, here when a trade is present, trade means a set of the 3 elements. When the set of the 3 elements is present, so what happens? The atomic mass of the middle element, the atomic mass of the or the atomic weight of the middle element is the arithmetic mean of the atomic mass of the other 2 elements. Arithmetic mean of the atomic mass of the other 2 elements, that only he said. So the atomic mass of middle element is equals to the arithmetic mean, that is atomic mass of the other elements, sum of the, for example, see here in this trade, lithium, potassium, sodium. So the atomic mass of the middle element, that is atomic mass of potassium, is equals to the arithmetic mean of the atomic masses of these 2 elements, that is atomic mass of lithium plus atomic mass of sodium divided by 2. So this is how the scientist Dobreiner explained his law in a set of 3 chemically related elements, and this set of 3 elements is nothing but trades. So the atomic mass of the middle element is the arithmetic mean of the atomic mass of the other 2 elements. So if you go for one more example, here there is a trade of the chlorine, bromine and iodine. If you calculate the atomic mass of the middle element, that is Br, that is exactly arithmetic mean of these 2 elements atomic masses. So this is how Dobreiner predicted his law. Next, one more scientist, Newland. He also gave one of the law that is called as Newland's law of the octaves. So oct, it means 8. Oct means 8. See here, when he arranged the elements in the increasing order of their atomic weight, see here in the previous cases they have considered atomic weight as a fundamental property. They have considered atomic weight as a fundamental property of the element. So here the Newland, when he arranged the elements in the increasing order of the atomic weight, so the properties will going to repeat at the 8th interval. It means 1, 2, so on, up to 8 elements are arranged. The property of the 8th element is similar to the first element. So he said that the properties will going to be repeat at the 8th interval. That is what we called as oct. So it is predicted as the law of Newland, that is Newland's law of the octaves. The properties of the elements will going to be repeat at the 8th interval, that is every 8th element has a similar, that is every first element and 8th element both are having the similar properties. Okay, so this is the Newland's law of the octaves. So after that one more scientist, that is Mendeleev, he contributed very much, or a high contribution of the Mendeleev is there for the periodic table. He discovered 63 elements. He only made that the rows and column distribution in the periodic table, and then the Mendeleev periodic law, what is the states? The properties of the elements are the periodic function of their atomic weight. He said that the properties of the elements are the periodic function of their atomic weight. So Mendeleev discovered at around 63 elements, and this his periodic table was very useful for us for further discoveries, and even he kept some space in his periodic table in order to in further or in future they will going to discover any new elements. For that he kept some space in his periodic table also for the discovery of the new elements. So see, here elements are having the different properties. When the elements combine with each other, there is a formation of huge number of the compounds. Okay, so basically we need to study the elements in a systematic way. That's why the periodic table is constructed. In order to study the elements in a systematic way, the periodic table is constructed. Next, now whatever we are following, that is modern periodic law. The modern periodic law was given by the scientist mostly. Okay, the scientist mostly gave the modern periodic law. So the modern periodic law is based on the atomic number. The modern periodic law is based on the atomic number. The law states that the periodic functions of the elements, the properties of the elements are the periodic functions of their atomic number. The properties of the elements are the periodic functions of their atomic number is what we called as modern periodic law, and it was said by the scientists mostly. And now whatever we are studying, that is about the periodic table of the elements, which is having the long form table. We are going to say it as a long form of the table, and this modern periodic table has the horizontal rows which are called as periods, and the vertical columns are called as groups. Okay, all the elements are properly arranged in the modern long form of the periodic table, and then in further also in our future we can able to discover many new elements, and those elements can be included in the periodic table also. Okay, so here let us go for the modern periodic table. So the modern periodic table, the modern periodic table consisting of the horizontal rows called as periods. Okay. 7 periods are there, and then vertical, it also consisting of the vertical columns. These vertical columns are called as groups. There are 18 groups are present. And this modern periodic table, for our convenience, for the study of properly, we are going to divide that into S block, P block, D block and F block. Okay. So here the modern periodic table is further divided into S block, P block, D block and F block. And then let us come to modern periodic table, that is a modern long form of the periodic table. See here, here as I said you, there are 7 vertical, that is horizontal, like this horizontal rows are present. 7. See here 1, 2, 3, 4, 5, 6, 7. Okay. There are presence of the 7 horizontal rows. These 7 horizontal rows are called as periods. These 7 horizontal rows are called as periods. Okay. And then here we are going to take the vertical columns. The vertical columns are, there are 18 vertical columns. There are 18 vertical columns, and these vertical columns are called as grips. See here, they have mentioned periods here. They have mentioned the periods here 1, 2, 3, 4, 5, 6, 7, 8. And then here, so here it is the long form of the periodic table. So this long form of the periodic table consisting of the 18 vertical columns. See here, vertical columns 1, 2, 3, 4, 5 up to 18. So these 18 vertical columns are called as grips. And then there are 7 horizontal rows like this, 7 horizontal rows, and 1, 2, 3, 4, 5, 6, 7. These horizontal rows are called as periods. Okay. And then this elements, that is periodic table, is further classified into 4 blocks. That is here group 1 and group 2 elements are the S block elements. And then group number 3 to 12, group number 3 to 12 are called as D block elements. Okay. And then group number 13 to 18 are called as P block elements, and here that is 4F series, period 6 and 7, that is 4F series and 5F series, these are called as F block elements. So how they are telling that these are S block elements, these are P block elements, these are D and F block elements? See here. And then this periodic table is very useful. See here, let us go for the one element. Suppose whatever the symbols they have written here, this is a symbolical representation of the copper Cu, and they have written the name copper, and whatever the numbers they have mentioned. See here, 29 is the atomic number, and then they have mentioned the electronic configuration. Here there is a boiling point, a melting point, atomic radius, density, here electronegativity value and ionization value, stability, all, and this is the crystal structure. Okay. And similarly they have said that here black coloration is there, means that is the solid, red is there, means that is the gas, blue is there, means liquid, and if this symbol is there, that is the what we can say radioactive. Even they have mentioned the structures like this cubic face centered, cubic body centered, monoclinic, everything is in detail, and one column or one element which you are studying in this box, it carries a lot of information regarding that element. Okay. So let us come to the that is the periodic table is classified into 4 blocks, S, P, D, F. So what is the S block elements? What do you mean by S block elements? The elements in which the last electron enters into the S subcell. The elements in which the last electron enters into the S subcell. For example, you can take hydrogen, which is having the atomic number 1, or else you can take the lithium, which is having the atomic number 3. What is the electronic configuration? 1s1. Here 1s2, 2s1. Here the electron, the last electron enters into the S subcell. That is why it is a S block element. And the general electronic configuration of the S block element is ns1 to ns2. In the periodic table, group 1 and group 2 elements are called as S block elements, and group 1 elements are called as alkali metals. See here, you can observe, see here, this is the color they have mentioned, and these are the color, these elements are the alkali metals. And then here group 2 elements are called as alkaline earth metals. Group 2 elements are called as alkaline earth metals. So this is S block elements. Then next one is P block element. P block element means again the last electron enters into the p subcell. The last electron enters into the p subcell and its configuration is ns2 np1 to ns2 np6. See here, the p block elements are present here. Group number 13 to group number 18 are called as p block element. If you wrote the electronic configuration, if you look at the boron electronic configuration, and boron which is having the atomic number 5, 1s2, 2s2, 2p1. So 1, that last electron is present in the p orbital, that is why it is a p block element. And then further, group number 13 is called as a boron family, as it starts with boron, and group number 14 is called as carbon family, group number 15 is called as nitrogen family, group number 16 is called as oxygen family, and and these are also called as halogens because of the ore forming nature, and group number 17 is called as halogens, that is this is halogen series, and group number 18 elements are called as zero group elements or noble gases or inert gases, and these are all the names for the group number 18 is having the different reasons. These are called as inert gases because those are having the inert in nature, and then those are called as zero group elements because their valence is 0. Those are called as rare gases because of rare nature, and those are called as noble gases because they behave like noble. They will not going to react with other elements. They maintain the stability. That is why these are called as noble gases. Okay. And next one more is D block element. D block element means here the last electron enters into the penultimate cell. That is, if n minus 1 is there, that is called as penultimate. See here, its general electronic configuration n minus 1 d1 ns2 n minus 1 d10. As you know, the D block has the capacity to accumulate 10 electrons, d1 to d10, and ns2 is there, and then it is a penultimate cell. N minus 1 means penultimate. So here group number 3 to group number 12 is called as D block elements, and these are also called as transition elements. And the characteristics of the D block elements are that is intermediate to S and P block element, because the D block is exactly situated between the S and P. So here it is intermediate, we can say intermediate to S and P block elements. And then here as we move from left to right, the metallic to non-metallic character will going to be increased. That is, there is a metallic to non-metallic character will going to be increased, and the D block elements starts with group number 3 to group number 12, and the D block elements are called as transition elements. Okay. And then one more block of the element, that is F block elements. As I said you, here the last electron enters into the F subcell F, and it is anti-penultimate cell. We can say n minus 2. See here the general configuration n minus 2 F1 and n minus 1 D0, ns2 to n minus 2 F14, n minus 1 D1 ns2. It means n minus 2 F is there. Here the electrons will be in the penultimate F cell. We are anti-penultimate. N minus 2 means anti-penultimate, and in the periodic table the F block elements are separately kept out of this main body of the periodic table, and these F block elements are called as inner transition elements. So these are called as inner transition elements, and these consisting of the two series. One is lanthanide series, that is 4F we can say, one more is actinide series, that is 5F series we can say. Here the lanthanide series will going to start with the lanthanum to lutetium, that is lutetium, and then actinide series will going to start from actinium to the lawrencium. So and this is kept separately from the main body of the periodic table. So this is how we can explain regarding the groups, that is how the groups are arranged into different blocks of the elements. And then one more thing I want to tell you, 7 periods are there. In these 7 periods, the starting 3 periods are short periods we are going to say, and other 4, these 4, that is 4 to 7, these are called as long periods. So, once again I will tell you for your convenience, the periodic table is classified into 4 block elements, that is S block element, P block element, D block element and F block elements respectively. The last electron, if it enters to the S, means that will be the S block element, if it enters to the P, means that will be the P block. How you can able to understand? Simply let us take the atomic number and write the configuration, and you will came to know where the last electron will enter to which subcell. If it is for S, means that will be S block element, if it is for P, means that will be P block element, if it is for D, that will be a D block element, if it is for F, that will be F block element. And starting 3 periods are the short periods, and further periods are long periods, and there are first and second groups are called as S block elements, and group 1 is called as alkali metals, group 2 is called as alkaline earth metal, group 3 to 12 is called as the D block elements, which are further called as transition elements, and then group number 13 to 18, those are called as P block elements. Group number 13 is the boron family, group number 14 is the carbon family, 15 is the nitrogen, 16 is the oxygen, and 17 is the halogen, 18 is the noble gas. And then F block elements are kept separately out of the main body of the periodic table, which includes 4F and 5F series, that is lanthanides and actinides. The elements are named here as lanthanides and actinides, which are having the 2 series, that is 4F and 5F. So, the further details of every element is described here in this box, and whatever the symbolical represent, that I have explained. Okay. In the next class, we are going to discuss about the properties like atomic radius, electronegativity, electron affinity, how it varies in the periodic table, that we are going to discuss in our next class. Thank you.